the HAWE Tech Podcast.
Hello and welcome to today's HAWE Tech Podcast. My name is Ralph and I'm Senior Specialist for Sales Enablement at HAWE. Today's question is, do you know what functions the hydraulics take on an automated materials supply? To answer this question, I've invited my colleague Ahmed, who is Key Market Manager for Stationary Applications at HAWE, and he's going to explain us a little bit about this. Welcome, Ahmed. Nice to see you again.
Thank you, Ralph. I'm also happy to be here today.
Great. Well, in a previous episode, we discussed the HAWE lifting system for platform AGVs. Specifically, we talked about the LOGAR system at that time. Today, I'd like to zoom out and explore the broader field of automation in logistics, focusing on how hydraulics fit into the picture. So hopefully you can tell us a little bit about it. And
yeah, sure.
Why don't you start?
So before we start, maybe I would like to start with some terms like AGV and AMRs. I'm going to use through this podcast only AGV. Both are the same. It's about how to control both of them, but they don't have a magnificent effect on the hydraulics. AGV, they need markers on the ground. AMRs are more autonomous. They have cameras and they can take decisions by themselves. But I'm going to use the term AGV. And if we talk about robots, as you said, LOGA is actually developed for the platform robots, the flat ones, which can go under a load, lift it, and transport it to another place. Another way of to classify, according to the forms of the robots for the logistics, is the AGV forklift.
Okay.
From the name, it's a forklift, but without a driver. It drives alone by itself. And the last form is the tugger. Tugger is the same, also AGV, but it doesn't lift any loads. It just only drags the load from one point to another. So by the first two forms, we have this lifting mechanism, and the last one not.
Okay. Is that the only way to classify the AGV sector, or is there another one?
Of course, there are a lot of forms to classify, or a lot of ways to classify the logistic robots. One of them is how the load and the capacity to lift a load. We are having loads indoors. They can reach maximum 2 or 2.5 tons. If you want to go more, I think it would be much more for an outdoors application.
Okay.
And we can reach up. We have projects where we have loads up to 80 tons even.
Wow.
So capacity of lifting a load is one of them.
Okay. That's very interesting. Now let's dive into the hydraulics part of this. And I'd like to ask you where hydraulics can be used in such robots.
When you think about hydraulics, it comes always in the mind the very classical applications, classical machines, heavy machines like excavators, or even industrial machines like presses and CNC machines. Many are surprised when they know that there's hydraulics in the AGV sector, or the logistic robot sector. The main application for the hydraulics in the logistic robots is, as we said before, is lifting the load and to transport from one point to another. Why? Because hydraulics, they have a very high energy density, which makes us able to produce and manufacture small hydraulic power units to lift very high loads through very high pressures.
Okay, so if I understand you, is that hydraulics are used for the lifting system for these logistic robots for its efficiency, mainly.
Yes. Yeah.
But you said in the field of robotics, hydraulics are not very popular, especially in this market. So how do you deal with that?
Exactly. As you said, not popular. And as I said, answering the previous question, that not many people know about hydraulics in the robots world. Usually our main customer is the mechatronic engineer. The mechatronics engineers, they tend to use more electromechanical system.
Okay.
And this leads that sometimes not the most optimum design is used because they never considered hydraulics. As we said, we have a high energy density, but because of very less contact to hydraulic world, these kind of very effective and very efficient systems are not used through the design of the robots. And what we try to do is that we try to be much more by the customer personally. We try to explain the hydraulics, how they work, and how they don't need too much energy and knowledge to use the hydraulics. And this is our way of trying to educate the market about how hydraulics can be used in the logistic robots.
Okay. Well, let's continue on educating them. Why would a customer use hydraulics over electromechanical systems?
There's not a very there's no general answer to answer this question.
Okay.
It depends on many things. It depends on the application. It depends on how the customer is considering his project or her project. Some customers, they say they want to have a cost-effective solution, then they will go for the electromechanical solution. Some customers, they want to have a more compact and more energy density solution, and they go for the hydraulics because, as we said, through a very small hydraulic power unit, we can lift high pressures or high loads, and this through this kind of solution, we can have smaller cylinders, and we leave space for other components like batteries, for example. We don't have shafts, we don't have gears, we don't have gearboxes, and our system is much more simpler than the electromechanical system.
Okay.
And that's how we see that the advantage of hydraulic systems in comparison with other systems.
Okay. Now, you've mentioned the LOGAR system a couple of times, and in this system, it was developed for the platform logistics robots. But are hydraulics used beyond platform robots?
Definitely. In a previous podcast, we talked about the platform robots and how we developed the LOGAR system by HAWE. But definitely we have other projects where we use actually different systems from hydraulics. If we go, we talked about this 80 tons EGV platform. So there are very big robots they use in airports, they use on harbors, and they lift definitely higher loads.
Yes.
In this case, we use a more classical hydraulics with a synchronizing block to assure the synchronization between the different cylinders. If we look at the forklift sector, also there are EGV forklifts where we use different systems. Now we are working on a project where we want to make our system much more energy efficient and more compact, again, to save weight and save place for other components. So actually we have different projects. You will be surprised to know that we have hydraulics in shuttle buses, autonomous shuttle buses.
Okay, I did not know that.
Exactly. So there are no drivers in these buses, but we have hydraulics in such applications. So hydraulics can serve different applications in the world of logistics and also autonomous robots.
Wow.
Principally.
Okay. Now, some manufacturers prefer the electromechanical systems due to concerns about leakage.
Yeah.
How do you handle that?
So I would consider leakages from the past. If a company can dimension and have a good processing of the project in the hydraulic world, and also by HAWE, we talked about LOGAR. By the LOGAR system, we tested our system up to 1 million cycles.
1 million.
1 million cycles. And if you look at the market, the lifetime of actuators on the market, they can go up to maximum 300,000 cycles. So we are much better, more than 3 times than the systems what we have on the market.
Right.
So if the company invests in such things, in tests and using the right parts, leakage should not take place.
Okay.
We have, after the test of 1 million cycles, we didn't see any wear, we didn't see any leakage because we have less mechanical parts. We transfer energy through oil, so we don't have gearboxes, we don't have shafts, all these mechanical pieces which can wear after a certain time are not there by our system, and that's why we do not worry about leakage that much.
Sounds good. Sounds like the customers shouldn't be worrying about it either.
Exactly.
It's quite impressive. You really gave us some ideas where and why hydraulic systems are installed in such robots like the AGVs and AMRs in logistics. In summary, you could have customers who build different robots like platform AGVs, indoors and outdoors, and also forklifts, AGV manufacturers.
Exactly.
Hydraulics are mainly used for the lifting function in
Exactly.
those.
Yeah.
And hydraulic systems can be best solution if the project is processed in an efficient way to save space and have a long-lasting working system.
I cannot sum it better than this.
That sounds really good, and I really like your passion and enthusiasm for this topic. So I'm really glad you came and explained this to us, and my door is always open. Come back and tell us more and different topics. So thank you very much.
You're welcome. Thank you for having me today.
And thanks to our audience for taking an interest in this very interesting topic. And if you'd like more, in 14 days, there will be the next HAWE podcast. So please join us, and we'll see you at the HAWE Tech Podcast in 2 weeks. Goodbye.